Hi all, this is Hamartaj from Department of Automobile Engineering, presently working at SJ Government Polytechnic. So today I'll be going to give you introduction on Parametric Modeling Unit 1, Session 2. A review of previous session. I had already explained you about these things in the previous session. So just let us have a review. What is CAD? CADD CAD. That means Computer Aided Design and Drafting. So computer aided design and drafting, you know that it is very simple for us to make CAD drawings rather than going for a manual drawing. Because in the manual drawing, it is very difficult to edit or to erase and do some of the modifications. So in CAD, it will be very easy to modify and to do the drawing and submit it. You can do it very easily, but in the manual drawing it will take a lot of time. Okay, I had told you all these things. Next one is parametric modeling. So in the sense, why this parametric modeling lab is needed. Parametric means, I told you, the shape of the geometry can be changed at any point of time. Not only once you are assembling the part, you're doing the assembly of one particular component. Just imagine. So what you will do, you will assemble and see that there some of the components are not matching over there. Then what and you have to change any one dimension. No need to disassemble the complete assembly and do it. You can just go for the parametric in the part drawing of that particular drawing, and you can just change it. Okay, in the whatever sketch you have drawn, part modeling, part drawing, there you can go and just you can do the any of the changes whatever you want, and automatically it will be changed in the assembly also. Okay, so likewise solid edge. So on the parametric modeling platform, we can use many of the softwares, that is solid edge, SolidWorks, CAD 3D, CATIA, ProE, etc. And but here we will be dealing with the solid edge. And what are the minimum requirements, hardware and software requirements for solid edge? For solid edge, minimum Intel or Athlon processor is needed, and hardware requirement I'm talking, and 2 GB RAM minimum is required. Above that, definitely it is okay. And software requirements, minimum Windows 2000 or Windows XP and above. Okay. Now, let us go for today's session now. Today we will be learning about the features of solid edge environments, important terms and conditions. So what are the features of solid edge? We are going to learn parametric design, process specific features, feature-based modeling, bidirectional associativity, interoperability with other CAD products. Now, what are features of solid edge? So parametric design. What is this parametric design? Solid edge designs are parametric. This means that the geometry of model is controlled by its parameters, such as dimensions and relations. For example, the parameters of a cuboid are length, width and height. You know that parameters of a cuboid are length, width and height. The rectangular block is driven by these three parameters. You can change the values of the parameters any time during the modeling process, and they are updated automatically. Not only in the beginning, say for example, when you draw a cuboid, three things are needed: length, width and height, and you have already entered those things in the part modeling. You will come out of the sketch art. Then what happens? You find that while in some part of the drawing, you will find that the length is not proper. So you can just go to that particular drawing and go for smart dimension and change the length over there directly. So no need of any other, you can directly change there. It will automatically be updated. Okay. Now, what is features based modeling? In feature based modeling, a model is divided into a number of features. The advantage of dividing the model into a number of features is that it becomes easy to modify the model by modifying its feature individually. Understood? Feature based model. When the feature is divided into, a model is divided into a number of features, then what happens? You can modify the model by modifying its features, that is individually. Any feature if you are applying, you can modify it anytime. If it is a circle, if you are giving any feature like you are doing like extrude command, you have given that extrude that you have not given the proper thickness of the how much it has to extend, then you can just go ahead and change over there individually. Okay. Process specific features. Process specific features are model features that represent forms and functions common in specific industries such as web networks. They have refined capabilities and are streamlined to perform with minimum user interaction. What is bidirectional associativity? The bidirectional associativity feature ensures that any modification in the model made in any environment is automatically reflected in the same model in another environment also. That means in the next slides we will be learning what are the environments. We have different environments like part environment, draft environment, assembly environment, sheet metal environment and weldment. In that environments, what happens if you have done anything in the part modeling and you are doing assembly, as I told you, no need to get worried and do any changes in the assembly. You can go back to the part drawing, and if you do the changes, automatically it will be changed here also. And in the draft, it is a detailed drawing, a detailed dimensioning of the part you will be getting in the draft modeling. There you can just go ahead and do it. Okay. Now, drawing views are generated in the draft environment. Okay, now that's what example here is given. When drawing views are generated in the draft environment, now you have done it. When the model is modified in the part environment, for example, simple holes are replaced by counter bore holes. Means you have done a drawing in the draft environment. Now when you come to the part environment, you feel that it is not the simple hole, you have to replace it by counter bore holes. Then if you do the change in part environment, that will automatically be updated in the draft environment. Next is interoperability with other CAD products. Solid Edge enables data transfer from other 3D systems such as Pro E through simple, powerful and trustworthy tools. This approach saves significant amount of time and money when compared to alternative approaches of translating data. That means if you have done any drawing in Pro E or CATIA, what happens? You have to transfer that into solid edge because it is a huge in companies and all they do. You have done a very big drawing that you cannot redraw it because it is time consuming. Then you have to transfer that data from other platform ProE or CATIA into the solid edge. Then you can easily do it with some of the trustworthy tools. It will save a lot of time and money also. Okay. Now let us come to the solid edge environments. Part environment. So this environment of solid edge is used to create parametric and feature-based solid and surface models. You can see here when you come to the part modeling, this is the the toolbar that will be at the top. When you are in the graphical user interface in the first screen above top here, these are the options you will be getting. So here you can see there is line command, rectangle, circle, this is fillet, okay, I think this is arc, and then you will be having, it's not that clear over here, there are the constraints or the relationships that you can give. Okay, this is connect, this is horizontal or vertical, you can make tangent. I'll be discussing this in the next PPTs. So this is what the page you will get when you come for the part environment. Next is your assembly environment. In the assembly environment, this is used to create an assembly by assembling the components that are created in the part drawing. First you have to do the drawing in the part drawing, part environment, then you have to call those parts in the assembly environment and then assemble it. When you come to the assembly, see this is the toolbar that you will be getting. Here you can see the insert component. This is the one which we have to click and then insert whichever component you need. Means you are creating assembly of any particular component. So component 1, 2 you would have named. You have to bring that into the assembly environment. So you have to click insert component and bring one by one the component. Okay. In the screw jack, for example, first you have to get the body, then the spindle, like that. Okay. Now, next is your draft environment. This environment is used for documentation of the parts or assembling in the form of drawing views. So here drawing views will be assembled. Okay. This is used for documentation of parts, mainly for the documentation purpose. Next is sheet metal environment. This module is used to create sheet metal components. Next is welding environment. Here what happens, once you have created the components, you can insert the components from the part or assembly environment and apply weld tools to the part or assembly. After creating the components either in the part drawing or in the assembly, then you can just do the apply weld to that part or assembly by calling the parts into that welding environment. Now let us come to the important terms. What you have to learn here is relationship. What are these relationships now? Relationships are the logical operations that are performed on the selected geometry to make it more accurate in defining its position and size with respect to the other geometry. That means you have done one drawing, okay, and on the selected geometry, in the sense any drawing part modeling you are doing, like say for example rectangle you have drawn, but you have not drawn it properly. It doesn't look like a rectangle at all. Simply 4 sides are there. Then what you can do is, instead of going and again bringing the rectangle, this first whatever you have created, deleting it, again taking it and creating, instead of that, in rectangle what happens, opposite sides will be equal. So you can select the opposite sides, make it equal, again the other two sides will automatically be equal if those two sides are equal. Okay, otherwise you can make those two sides also equal. Okay, likewise many things are there here, like end point, midpoint it will show, and center point it will show. You have to check these things also, very important, because while doing a drawing, when you move the cursor itself, it will show which is end point, which is midpoint, and which will be very helpful for you to create a drawing. When perpendicular, it shows, either it shows here or you can select there and then do it on the drawing itself. Okay. Next, in these relationships we have geometry relationships. These logical operations are performed on the basic sketched entities to relate them to the standard properties such as collinearity, concentricity, perpendicularity, and so on. Now let me give you example of these geometry relationships. Few examples. Connects. What is connect? Connects two lines together. See, this is the connect command. When you click this, what happens is, there are two lines. You have already done a drawing. By mistake, the continuity of the line was not there. Then what happens, when you no need to again go extend the length or those things, choose those two lines and just give the command connect. Those two lines, if there is any gap, it will be fulfilled. Those two lines will be connected with each other. Concentric. It makes two arcs or circles concentric. That means you have drawn two circles, but the center of those two circles is not same. But in the drawing, it is necessary. What you will do, no need to delete it and do it. Just click on concentric and select those two circles. They will become concentric automatically. Not only not only circles, but arcs also will become concentric if you will apply that command on arc. Next one is horizontal or vertical. It makes two lines horizontal or vertical to each other. This is the one. Yeah. In the geometry, you have to change any two lines. You have to make one line horizontal to the other or one line perpendicular to the other. You can always go ahead and use this command. Next one is collinear. It makes two lines collinear. Collinear in the sense, two lines are there but they are not in the same line. In the geometry, you might face those kind of problems. Then what you can do, click that. No need to delete that drawing or that particular two lines. Just select those two lines and click on collinear. Those two lines will come in the same line. Next one is perpendicular. Perpendicular, you know very well, like this. Okay. One line vertical, one line horizontal, 90 degree. It makes an element perpendicular to another element. Okay. See here. So you have to make some line which is tilted like this. It might be at an angle tilted and the other line is already horizontal. Then you can make those two lines, select and click on perpendicular. That two lines will become perpendicular to each other. Now tangent. It makes two elements or series of elements tangent. See, you might be having problem like two circles are there, three circles are there, but you have to draw a line tangent to those circles. Then click on the this tangent and draw the line. what happens to that circle, that line will be a tangent. Next is equal. It makes two lines or two entities equal. As I told you in the second or third slide, that equal means it makes two lines or two entities equal. You can just click that command. Symmetric. It makes exactly similar parts facing each other or around an axis. Okay, two parts you need to make it symmetric, then along, around the axis you can make two parts symmetric to each other. Now this is rigid set. It makes elements rigid by creating a set whose geometry behaves as a single unit. Means you have drawn some particular part, okay, one rectangle, triangle, whatever it is. What you can do is, or a complete part for that matter, when you click this rigid set, what happens is the whole geometry will behave as a single unit. You have drawn one rectangle, then connected, then drawn circle at the corner. You want to, you have drawn any simple drawing and you have to make it as a single unit. Okay. Then, or it, what happens is after joining two parts also you can make it. Click it, and it will become a single unit. Okay, that is rigid set. Okay, now that's all for today. Now let us come for assessment. First one is, the model created in Solid Edge is a combination of number of features that are integrated together to complete the design. True or false? Model created in Solid Edge is a combination of number of features that are integrated together to complete the design. Yes, it is true. The advanced modeling tools appreciably reduce the time taken in creating the features in the models, thus reducing the designing time. True or false? Definitely, it will reduce the time. Therefore, it is true. Now, to make two circles or arcs to have common center point, which relationship is used? Concentric. You are making two circles or two arcs to have a common center point. When you have to make two lines parallel to each other, which relationship to be used? Parallel. Parallel, there will be two parallel lines that you have to select. Which relationship makes exactly similar parts facing each other? It is symmetric. It makes two parts, okay, facing each other around an axis to, exact two similar parts facing each other will have the, will be same, okay, will be symmetric to each other. What are the types of environments in Solid Edge? There are 5 environments: part environment, draft environment, assembly environment, sheet metal environment, and weldment environment. Why are the geometric relationships important? To make the geometry or the drawing, precisely correct or perfection, in the sense to edit the drawing easily and to make it precise drawing. Easily you can make it, rather than instead of erasing it, instead of making any corrections, you can directly go ahead and click on the relationships. It will make the those two lines perfectly either collinear or perpendicular to each other or parallel, whatever it is. To get the precision and perfection in the drawing, we use the geometric relationships. Now thank you. That's all for today. Let's meet in the next session.